The MOVIDRIVE B has been our flagship inverter for a while and is our most flexible VFD that we sell all over the world. It is based on a modular platform, so there are a lot of components that we can add or remove, which gives them the capability to work for countless applications. One of the main reasons the MOVIDRIVE is so popular is because it can operate almost any type of AC motor. It can run standard asynchronous motors, open or closed loop. It can operate permanent magnet servo motors that have resolver or absolute encoder feedback. And it can operate linear motors. If you've never seen a linear motor, it's essentially a servo motor that has been unwrapped and is used for precision linear positioning. Let's summarize some of the key features of the MOVIDRIVE. Just like a simple VFD, the MOVIDRIVE can do simple speed control. It can control the motor torque directly for applications like winders and mixers that need a specific constant torque to operate properly. It can do positioning, and it does it very well. It can even be connected to other MOVIDRIVEs for master and slave positioning, which is called synchronous control. It can be operated in open or closed loop control. It can be commissioned to work in all of the different control modes that we discussed in the previous training session. It has a built-in programming language called IPOS Plus that opens the ability for countless types of customizations. Finally, it has application modules. These are pre-written programs that use a graphical interface to input some details about the application. The customizations are loaded in the background, which give the MOVIDRIVE the ability to accomplish sophisticated tasks that couldn't be configured just with using the standard parameters. One of the highly desired capabilities of the MOVIDRIVE is the IPOS programming. The IPOS feature is very powerful and in some cases eliminates the need for a lower level dedicated PLC to control the MOVIDRIVE. A common way IPOS programming is used is to handle all the lower level tasks such as positioning, mathematical unit conversions, and specific types of travel sequences. Doing these tasks within the MOVIDRIVE removes the computing load from the upper level PLC. Also, the MOVIDRIVE can perform the operations much faster because it doesn't have to wait for the timing lag back and forth that comes with using an external PLC to manage all of the logic. The IPOS language is a streamlined version of the C programming language, so it makes it quite simple to write a custom program from scratch if the programmer has had C experience in the past. The programming tool is a part of our free MoviTool software, so there isn't any software you have to pay for if you want to create a custom IPOS program for your application. As a side note, if the MOVIDRIVE is using a custom IPOS program, it is good practice to share the correct file with colleagues that may need it. Once the code is compiled and downloaded, it's not possible to extract the pre-compiled code from the MOVIDRIVE. If someone connects to the MOVIDRIVE without a copy of the code, all they can view is the assembly language version of it, and they can't make any edits to it. Having a copy of the code on hand will make troubleshooting much easier if problems happen later on, and it's the only way to make edits without starting from scratch again. So those code files are extremely important to store in an easy-to-find location. We understand that not everyone is a programmer or will want to create a custom program for each of their applications. So we have application modules that act as a bridge between the standard MOVIDRIVE parameters and a custom IPOS program. We have around a dozen modules to choose from that are tailored for different applications, like palletizing, flying saws, winders, turntables, positioning, master-slave synchronization, etc. The application modules are a lot easier to work with because all you have to do is answer some questions about the application. Then, customized IPOS code is created in the background, so you don't have to figure out how to program the customizations and math functions from scratch. Each application module is well documented, so setting it up and mapping the process data words on the upper level PLC is straightforward by referencing the manual. We actually recommend using our application modules over creating a custom IPOS program if it meets all of the application needs. From a technical support standpoint, we know how the application module works and can locate errors in commissioning easier. If a MOVIDRIVE is using a custom IPOS program, we most likely won't have a copy of it, and the program probably doesn't have any accompanying documentation, so it can be very challenging to troubleshoot if problems were to come up later on. We will set up an application module in our lab exercises, so you will get to see what that process looks like. Let's cover some other helpful topics you should know. The first one we'll discuss is operating temperatures. The MOVIDRIVE is designed to work in temperatures ranging from 32 to 104 degrees Fahrenheit. There are applications like cold storage or furnaces that need positioning, and our MOVIDRIVE is used in a lot of those applications. But the MOVIDRIVE has to be installed in an area that can regulate the temperature into a safe level. Oftentimes, this means the electrical cabinet has its own air conditioning unit, or the cabinet is a good distance from the application where these temperature limits aren't exceeded. The storage limits are a little wider. For example, if the MOVIDRIVE is stored in a non-temperature regulated warehouse and it fluctuates in the winter or summer seasons, that's okay as long as it's not operated at those temperatures. The really important thing with storage is to make sure it remains dry and condensation isn't happening on the MOVIDRIVE. These MOVIDRIVEs are only rated for IP20, so it can be damaged if it comes in contact even with small amounts of moisture. Another note about storage is that we recommend for any long-term storage that the spare MOVIDRIVE is powered with its rated line voltage for 5 minutes every 2 years. The MOVIDRIVE has electrolytic capacitors that can degrade if they don't see any voltage for extended periods. If you have any MOVIDRIVEs that have been stored for over 2 years, it can be salvageable, but you have to bring up the voltage slowly with a variable power supply over a 1-hour procedure that's shown in our manual. If voltage isn't brought up slowly, the inrush of peak voltage could cause capacitor failure. If you don't have a variable power supply, our electronics repair lab can do that for you if you have MOVIDRIVEs that have been stored for longer than 2 years without power. In some scenarios where the ambient temperature can't be kept below 40 degrees Celsius, it is possible to still operate the MOVIDRIVE at those temperatures, but the output power rating has to be derated by 2.5% and 3% per degree of Celsius above its maximum. For example, if the ambient temperature during the summer causes the electrical cabinet to get to 60 degrees Celsius, which is 140 degrees Fahrenheit, this means the MOVIDRIVE's power capability is reduced to 50%, and it should not be utilized higher than that until the ambient temperature decreases. The MOVIDRIVE has very good overload capacity. The MOVIDRIVE is designed to handle 125% overload capacity continuously and be okay as long as the ambient temperature limits aren't exceeded. As an example, this could be helpful if the application needs temporary higher load capacity while another machine is down for maintenance. For times when there is a lot of startup torque needed, the MOVIDRIVE can output 150% for a total of 60 seconds. A lot of applications that are start and stop will only need 150% for a few seconds, so as long as there is sufficient cooldown periods between cycles, the MOVIDRIVE could go to 150% in these brief periods throughout the day and be okay. However, if the MOVIDRIVE is continuously reaching 150% and holding it steady, then there is likely a mechanical issue occurring that would need to be resolved. Our smallest MOVIDRIVEs have a little bit higher overload capacity at 200% for up to 1 second. If you're installing a MOVIDRIVE, it is listed in the major certifications and will have the certification it meets listed on its side label. When you go to install the electronic hardware to meet these certifications, each one has numerous rules which will vary all over the world. So if you need more information about this, our MOVIDRIVE system manual goes into more detail about how it should be properly installed to conform to these certifications. Now let's discuss some of the models of the MOVIDRIVE to make that clear, because it can be confusing if you weren't shown how to decode the different variants and the model type. Just a reminder, we are a European company, so most of our documentation is going to be listed in a metric system. This means dimensions will be in millimeters and power ratings in kilowatts. Sometimes there are conversions to imperial units for inches and horsepower, but this isn't always the case, so you will need to be comfortable with converting from metric to imperial units at times. If you need to convert kilowatts to horsepower, that can be done by using the relationship that 1 horsepower is almost 3/4 of a kilowatt. If you know what horsepower you have and want to know what it is in kilowatts, you can multiply your horsepower by 0.746 and get the equivalent kilowatt. If you're given a kilowatt value and want to know what that means in horsepower, you can divide the kilowatt value by 0.746 to get the equivalent horsepower. You can use these two conversion formulas to go back and forth as needed. If you need to convert measurements, the relationship from imperial to metric is 1 inch is about 25.4 millimeters. You can use the same multiply and divide relationship above to convert between these units as needed. Here are all the size variants of the MOVIDRIVE. They come in 8 sizes. For reference, size 0 at the top of the image is about the size of a textbook, and size 7 on the far left is about the size of an ATM. Now these are just the frame sizes, but within each of these is multiple different variants. Also, within each frame size, there can be 2 or more different kilowatt ratings. And finally, the MOVIDRIVE does support 230 volts in some of its sizes, so you will see some 230 volt compatibility in a handful of these frame sizes, but not all of them. I briefly mentioned it in our last training session, but the MOVIDRIVE doesn't have any options for single-phase voltage like you would find in a residential environment. So these voltage ratings are only for 3-phase. I want to clarify some things with some of the MOVIDRIVE sizes that are a little different than the others. If you noticed in the last picture, there were 4 variants of size 0, and this is because each size has 2 different versions. For size 0, there are 0S and 0M. You can think of that as small and medium. These range from 0.55 kilowatts to 1.5 kilowatts. So these are the lowest output power MOVIDRIVEs we offer. Within those 2 sizes, there is this version that doesn't have any expansion slots. We call this option the MDX60B. These MOVIDRIVEs can only be open loop control because they have no ability for an encoder option card. Since they don't have any expansion slots, that means they can't have built-in field bus options or expanded inputs and output options either. So these are very different than the rest of the MOVIDRIVE line. The other version available in these sizes is the MDX61B. This does have expansion slots, so these can have encoder feedback and other options as well. Because these are the smallest MOVIDRIVEs we make, they only have 2 expansion slots. The rest of the MOVIDRIVEs all have 3 expansion slots. The option cards in the smaller size also install differently. This black plastic cover snaps over them, covering the option card mounting screws. It is possible to swap the option cards out in the field, but you have to be careful not to break the plastic cover or the option card since it's a little more challenging to get access to. The next size that has multiple variants is size 2. Feature-wise, these have the same capabilities, but this is only a dimensional difference because the size 2S supports about 5 horsepower less than the size 2. Here are the other sizes which have the same amount of expansion slots. You may notice something similar here between these, and it's the control sections on the front. They are the same between all the sizes. The thing that changes between these is the power section that is behind the control section. Now you may be wondering if you can swap these around if one of the inverters is faulting. And that is only sometimes true, and we don't recommend doing that. When the control section is swapped around, the parameters could be accidentally wiped, or it can cause the MOVIDRIVE to not work correctly because of firmware mismatches. When we assemble these in the factory, there are 2 separate firmware packages that get written in the control section and in the power section. If the control section is swapped around and ends up on a power section that has a different firmware than it expects, it can cause faults and be hard to diagnose. So don't count on being able to do that as a troubleshooting step or as a way to manage spare part inventory. There have been some customers that have swapped control sections and have gotten their MOVIDRIVEs to work again, but doing that isn't good troubleshooting practice because the underlying problem was never determined, and it will cause the replacement control section to fail later on. Now let's summarize power and voltage ratings with a picture of what the MOVIDRIVE would look like. Here are the power ratings for the size 0 that we discussed earlier. Size 1 has the most power options, and it's the smallest option we have that supports 230 volts. This is the size that we will be using on our demo units because it's as small as we can go while keeping 3 expansion slots. In size 2, we can see the 2 different variants and the power ratings here. Here is what size 3 will look like. The power section gets much larger in the jump from size 2 to size 3. This is size 4, and it's the last size that supports 230 volts. Here is size 5, and to get a reference of how large this is, it weighs about 77 pounds. This is size 6, and it stands around 3 1/4 feet tall. Finally, this is size 7 that has a maximum power rating of 250 kilowatts, which is around 335 horsepower. It weighs in at a whopping 617 pounds. You may be wondering what kind of application would need that much power. Well, we've seen these used in recycling machines that grind up catalytic converters from automobiles to reclaim the platinum. We've also seen this in a large amusement ride that spins vertically, and it has 8 motors being driven by a single size 7. So they are out there. In the last session, I said that the MOVIDRIVE B is based on the MOVIDRIVE B platform, and this is how. The power sections between the MOVIDRIVEs and the MOVITRACs are the same. The only difference is the control section. This is how the MOVITRAC and MOVIDRIVE can have very similar parameter sets because they use similar parts. The same recommendation applies to not swap the control section around as a troubleshooting step. Let's look at an example model type that you would find on the side label of a MOVIDRIVE and discuss what all these letters and numbers mean. The type code will always begin with MDX, and this just means the MOVIDRIVE series. The letter B means the B version. This is the version this training course is dedicated to. The older MOVIDRIVE version was the A version, which is steadily being discontinued because parts for it are becoming no longer available. The 60 and 61 is what we showed before, which means without or with expansion slots. Remember, only the smallest MOVIDRIVE has the option to not have any expansion slots. The 4-digit number that follows is very important, and it is the output power rating in kilowatts. If you just remember that there is an imaginary decimal place between the last 2 digits, you can easily determine what output rating the MOVIDRIVE is. So a number of 0011 is 1.1 kilowatts. The next digit indicates the rated input voltage. The 230 volt range will have a 2, and the 460 volt range will have a 5. The letter and number that it's grouped with is what type of line filter it has, and the last number indicates that it's a 3-phase supply. Once you get into the larger power MOVIDRIVEs, they don't come with internal line filters, so its type code would automatically be 503, for example. The next section is if the MOVIDRIVE can have a brake resistor or not. All our MOVIDRIVEs can have a brake resistor except in the size 7 because it can be built without that brake chopper circuit if the application doesn't need it. This would be a special case though. Finally, the last 2 digits are also very important. The last 2 digits indicate what programming level the MOVIDRIVE can support. All of our MOVIDRIVEs support IPOS programming, but if you want to use any of the application modules or special features of our MOVIDRIVE, like synchronous operation, camming, etc., it would need to have the 0T technology package loaded to it. If you try to load an application module or an advanced IPOS program to a MOVIDRIVE with just the standard IPOS level of 00, the MOVIDRIVE will issue a fault code that can't be cleared until the technology level is corrected. We do see this occasionally where the wrong IPOS level is ordered and the replacement MOVIDRIVE issues a fault when the parameter backup is loaded. This can be fixed in the field though. The 0T technology level can be ordered afterwards with our customer service department, and we can issue a unique software code for the serial number of the MOVIDRIVE, which will unlock the technology level. To avoid having an incorrect order in the future, we recommend that you write 0T added somewhere on the MOVIDRIVE with a marker that's easy to see, or you can have your local salesman visit the plant to install the correct model label that will show that the 0T level has been added. We aren't able to send a replacement label directly to the customer because of the certifications it has printed on it. So it will have to be installed by an employee of SEW if you want to go that route. All right, let's look at the hardware of the MOVIDRIVE. Just as a reminder, the MOVIDRIVE is often operated on 460 volts, and because of its half-wave input rectifier, the DC bus level is steady around 700 volts DC and can reach 1000 volts during regenerative operation, so be very careful when working around it. All MOVIDRIVE Bs include a memory module that is on top of the MOVIDRIVE. At first glance, it's easy to think that this is a start-stop switch because of the shape and it has the word stop on it, but it's not a switch. The reason the stop text is there is to remind you not to pull this out while the MOVIDRIVE is under power. The purpose of the memory card is to make replacing the MOVIDRIVE easier. If the card hasn't been corrupted, then you can move the memory module from the old MOVIDRIVE to the replacement MOVIDRIVE without having to use the keypad or computer to transfer the parameters and any IPOS programs. As a warning, you should never power on the MOVIDRIVE without the module installed. This was more of a problem in the older MOVIDRIVE Bs, but still, don't do this. For example, if an older MOVIDRIVE is accidentally powered without the module, once the module is installed, the data on it could be scrambled, which corrupts the parameter file and makes it unusable. The only way to recover the parameters after that is to have a pre-existing backup on a keypad or computer. If the parameters have never been backed up, then the MOVIDRIVE would need to be commissioned from scratch to get it operating again. This could be difficult, especially if a custom IPOS program or application module is being used. In 2018, we had to make a circuit change to our memory modules, so any of our new MOVIDRIVEs will have this black dot underneath the stop text. This dot represents the new version memory circuit board. The reason this matters is because of compatibility. An old memory module that doesn't have the black dot is compatible with any version of our firmware, even the newest firmware. The new module that has the black dot will not work in an older MOVIDRIVE with older firmware. It only works in firmware version 22 or higher. Let me explain this with a couple examples. If you had an old MOVIDRIVE and it needs to be replaced, and you install a new MOVIDRIVE, you can put your old memory module in the new MOVIDRIVE and it will work okay. However, let's say you already had a new MOVIDRIVE installed, and for whatever reason it doesn't work and needs to be replaced. You check the stockroom and find an old MOVIDRIVE there. Well, you will not be able to install that new memory module with the black dot in the old MOVIDRIVE. The only way to get the old MOVIDRIVE to work is to use the keypad or a computer to transfer the parameters. If you need your firmware updated, we recommend that you take great care when doing that, because if the process is interrupted or has any hiccups, it will brick the MOVIDRIVE. The only way to fix it at that point would be to have our repair lab open up the MOVIDRIVE to access the circuit board to restart the firmware upgrade process. If you want to do the firmware upgrade yourself, we have a piece of software on our website that can do that, but you must know that the process can't be interrupted or the MOVIDRIVE will be unusable until it's fixed. As a side note, our MOVIDRIVE doesn't require regular firmware updating. We only update firmware on a case-by-case basis. If you don't want to have to remember all these rules with swapping memory cards and what firmware is supported, then this training course will show you how to back up and restore parameters with the software, which is the preferred way to manage the parameter files. Let's move from the top of the MOVIDRIVE to the front of the MOVIDRIVE and talk about the connectors that are there. The AC line voltage input is on the top of the MOVIDRIVE. Directly beside it are the DC link terminals, so don't get them mixed up. The reason there is access to the DC link is for troubleshooting and for external components that we offer, such as regenerative energy storage, and some of our motor brake controllers are only powered by high voltage DC instead of using the AC line voltage. Before doing any troubleshooting, you would want to measure the DC voltage at these terminals and make sure all the voltage from the capacitors has dissipated. It takes several minutes to come down from 700 volts after the power is switched off. The brake resistor, which also operates from the DC link supply, is underneath the MOVIDRIVE, so the voltage you measure at the DC link will be the same at the brake resistor terminals. The motor terminals are beside the brake resistor terminals. Then there's a small connector on the front left-hand corner, which we call the STO terminal, and it stands for Safe Torque Off. From the factory, we supply it with 24-volt jumper wires, but what some customers will do is remove these jumpers and feed in their own 24 volts from a functional safety controller. The purpose of the STO circuit is to immobilize the motor from turning. It does that by removing the control voltage from the output transistors. It's important to remember that this is not a lockout tagout, and it doesn't make it electrically safe to work on. There is still 460 and 700 volts present, and the MOVIDRIVE is still powered. As soon as the 24-volt STO signal switches back on, the MOVIDRIVE will start operating again without warning. You will always need to electrically and mechanically lock out the machine to do any work on a MOVIDRIVE or motor. If the STO circuit is tripped, the MOVIDRIVE will display a capital letter U indicating this. So if you're trying to operate the MOVIDRIVE and the motor isn't turning and you see a U on the display, that means the STO is tripped and the safety circuit needs to be reset, like closing a safety gate or pressing a safety acknowledgement button if the machine is safe to operate. The front terminals on all of the MOVIDRIVEs are identical. The first row of terminal blocks shown here are for the low voltage inputs and outputs. In the variants that have expansion slots, the motor encoder card always installs in this lower left slot for closed loop control. The slot above it is where a field bus option card would go if you are wanting to connect the MOVIDRIVE directly to the plant network. On the size 0 MOVIDRIVE, there are only 2 expansion slots, so this is the max it can be expanded to. But on size 1 and up, you have a third slot, which is much taller, which is used for our feature expansions like master-slave option cards, external encoders, additional inputs and outputs. All MOVIDRIVEs have a 7-segment display. This shows you at a glance what operating condition the MOVIDRIVE is active in. This is also the location where the faults will flash if they occur. Directly below that is a jack that resembles a telephone port. This is the X terminal where we connect our RS-485 computer cable so we can communicate to the MOVIDRIVE with our MOVITools software. When you're not connected with a computer, this is also where the keypad communicates with the MOVIDRIVE. Below that is a small bank of dip switches. These change the RS-485 communication speed, which is called a baud rate, and it also configures the analog input to be a voltage signal, such as -10 volts to positive 10 volts, or a current signal, such as 4 to 20 milliamps. No matter what power rating MOVIDRIVE you're working with, the front panel will be identical except the amount of expansion slots. Lastly, not every card can fit in every slot, so don't try to force it. I already mentioned how to access the card's mounting screws in the size 0 MOVIDRIVE by unsnapping the black plastic cover on the right-hand side. In the size 1 and higher MOVIDRIVEs, the option cards are installed on sliding brackets that are held with Phillips screws on the front. Once the front screws are removed, the whole bracket slides out on a rail, giving access to the cards if you need to swap them out. You are allowed to add and swap cards as needed. Just be careful with them because you are handling a fragile circuit board that connects to the MOVIDRIVE with very fine pins at the rear of the option card. We see this a lot in the field and in our repair lab, so I'll mention it here, that you shouldn't ever crank down on any screws of the MOVIDRIVE. Whether it's the power terminals or the option card screws, these should only be snugged with just finger pressure. If the wire is easily pulled out, then you need to use ferrules on the end. If you're really torquing on it with your wrist, that is already too much torque, and that is running the risk of stripping the screw, which sometimes completely damages the terminal. Especially with the power input and motor terminals on some sizes of MOVIDRIVE that are built in and non-removable. All MOVIDRIVEs have basic input and output terminals that work on 24 volts. There are 8 digital inputs, 4 digital outputs, 1 analog input that can be voltage or current based, and 1 temperature sensor input from the motor stator. There is 1 programmable low voltage relay that switches depending on the parameter setting, and there is 1 brake control signal that connects to an external brake controller so the brake timing is accurate and reduces sagging or drifting issues of the motor. Of those digital inputs, one of those is named DI00. This is permanently assigned to controller inhibit. This prevents the MOVIDRIVE from enabling somewhat like the STO circuit, but it operates on a different control principle. If you see a solid number 1 on the 7-segment display, this means the inhibit terminal doesn't have voltage and it's keeping the MOVIDRIVE from enabling. Whether you're using a field bus to control the MOVIDRIVE or just the inputs, you'll need to find a way in your circuit design to get constant 24 volts to this terminal when you want the MOVIDRIVE to operate. Also built into the MOVIDRIVE is this terminal block called S-bus, which stands for the system bus. This is a CAN-based protocol that gives us the ability to daisy chain communication between multiple MOVIDRIVEs. This is especially necessary for synchronous operation or when using an external field bus card that sends process data to each address it sees. There are limitations on how many MOVIDRIVEs you can connect together. The absolute maximum is 64 units if you're only connecting MOVIDRIVEs together. But if you're using an external field bus or some type of synchronization, this limit comes way down to a max of 8 or 16 units for each external device. This limit depends on what kind of external device you are using. Let's mention some miscellaneous extras. The most full-featured way to interface with the MOVIDRIVE is with our software. You'll need a communication cable to do that if it doesn't have a field bus card installed. One of these cables is called the USB 11A, which has been out for many years and only supports the RS-485 protocol. This cable is actually being discontinued this year. It is being replaced by the USM21A, which includes RS-485 and now adds CAN communication. This new adapter opens up the ability to communicate with almost every electronic product we've made, ranging from the old MOVIDRIVE A all the way to the newest MOVIDRIVE Generation C. We have different plugs that can adapt it to the various ports on each inverter. Another common accessory you'll see is this DBG60 keypad. This allows you to see full text descriptions of fault codes. You can view, modify, and back up the parameters, and you could operate the MOVIDRIVE in manual mode with a keypad during troubleshooting if you had to and there wasn't a computer nearby. Another thing you may encounter are these yellow option cards. These are for functional safety control, and you have to be extremely careful when working with these because they connect into other safety circuits and are crucial to any safety certifications the machine may have. These option cards require a whole different software package to work with them that we won't be showing in this training series. This is because if any of the parameters have to be changed, it has to be done by someone that has went through a functional safety certification process. If you're not safety certified, the only thing you will be able to do with these cards is relocate them to a replacement MOVIDRIVE. You will not be allowed to remove them completely from service because that breaks the functional safety control chain. We have a functional safety department that manages and supports this hardware if you have one and need support with it. Another important switch that is in this bank of dip switches is the S-bus terminating resistor. This must be switched on if you are using the S-bus terminals for connection to other MOVIDRIVEs or to external field bus cards. The rule for the termination is that the first and last device in the S-bus network needs to have the resistor switched on. All the devices in the middle will have their resistors switched off. This resistor lets the S-bus know where the ends of the network are. If this switch is forgotten, then the S-bus network may not work, or it can drop communication, which may cause the MOVIDRIVE to start and stop sporadically. The first line of defense to know what is going on with the MOVIDRIVE is the 7-segment display. Some of these numbers are just informational for what mode the MOVIDRIVE is in. I've already mentioned a couple of these, like a solid 1 is for controller inhibit, and U means the STO terminal is tripped. Other common ones is the letter A. This is sometimes confusing because someone will see the motor isn't moving, but the display shows A. This means the MOVIDRIVE is enabled and there is an application module or custom IPOS program controlling it. When a program is controlling the MOVIDRIVE, it sometimes is waiting for a go signal from the PLC. So if you ever see an A and the motor isn't doing anything, that doesn't mean there is a problem with the MOVIDRIVE. The IPOS program is probably just waiting for the next command to know what to do. The other common ones are number 4, which means the motor is running in open loop mode. The number 5 says in control, which means closed loop speed control. The number 6 says M control, which means torque control. If the inverter is flashing a capital F and a number that follows it, it is indicating an active fault code. Our manuals have numerous pages describing what each fault number means and some common things to check to resolve it. We won't go over every possible fault in this training course, but we will discuss in a later session what some of the most common ones are and things you should check if you encounter that fault code. Something that is very easy to overlook is in this bottom right-hand corner of the 7-segment display. This is a location for a blinking decimal light. This blinking light means that there is IPOS code loaded to the MOVIDRIVE and the processor is cycling through the commands. This IPOS code could be custom or it could be an application module. We wouldn't know what the code is unless we connected to the MOVIDRIVE with the software and took a look at the parameters to see how it was commissioned. When you replace a MOVIDRIVE that used IPOS code, the processor should restart automatically if the parameter backup was done while the program was running. If the program isn't running for some reason, then it can be restarted using the software, which will cause the light to start blinking again. Finally, if you see the capital F and it's backwards, then this is very bad. It means the MOVIDRIVE needs to be sent into our electronics repair lab to evaluate if it can be fixed. Otherwise, it would need to be completely replaced. This is rare to see a backwards F, but it does occur, and that condition can't be rectified with any troubleshooting in the field. All right, we have reached the end of our second session. In this session, we introduced the key features of the MOVIDRIVE, its overload capacity, and its temperature limitations. We learned the various models and power sizes of the MOVIDRIVE B and how to interpret the model type code. We discussed the purpose of the red memory module on the top and some rules that go along with moving it from one inverter to another. We showed the different connector locations on the MOVIDRIVE and what their purpose is. Finally, we discussed some common accessories that you will use with a MOVIDRIVE, and we went over the 7-segment display codes and what they indicate. In the next session, we will go in depth with the external hardware the MOVIDRIVE could be operating with, such as power filters, I/O expansion cards, and field buses. We'll also go deeper into the closed loop